is this a function or not? Anybody, is this a function?
Would it be a function because it passes the
Vertical
test?
Absolutely, perfect. Can anyone identify the domain of this function?
Is it -2 to 2?
That's it, with 2 parentheses and -2 bracket. Perfect. Can anyone identify the range?
Is it 0 to 3?
That's it. Is it increasing, decreasing? Is there an interval of increasing, an interval of decreasing? So is this function increasing? And if it is, on which interval is increasing? Not from which number to which number, no. The trend of increasing is for which values of x? The increasing trend is for values of x between what and what?
Between 1 and 2?
That's it. And it's decreasing for x values between what and what?
Is it -2 and 1?
That's it. Is this function ever constant? It's never constant. It goes down and up. Good. Does it have a local max? It does not have a local max because the local max can never be at the end points of the interval. Does it have a local min? Yes, it has a local min at x equals 1. How much is the minimum? What is the value of the minimum?
Would it be 0?
That's it. That's it. How much is f of 0?
Would it be 1?
Perfect. Does it have an x-intercept?
Would it be at 1, 0?
Perfect. How much is x when f of x is 3? When f of x is 3, how much is x?
It would be 1.
So let's discuss this for 1 second. I'll come back to the graph. When f of x is 3, we're asked to find x. So this is y equals 3. I have to imagine that I draw a horizontal line that is y equals 3 and see where it crosses the graph. And that would be the x value. So draw a horizontal line, y equals 3. See where it crosses the graph of the function and read the corresponding x value for that point. How much will that be?
Would it be -2?
Perfect. Let's try one more. F of x equals 2. What is the corresponding x value when y is 2?
Is it -1?
-1. See, we had a 5-minute discussion on this tiny little thing. Increasing, decreasing, max, min, finding values, domain, range, x and y intercepts. A lot of discussion on a tiny little thing. Okay. So, yes, let's also look at solving polynomial inequalities and rational inequalities. For example, -x, x plus 2, -x plus 1 less than or equal to 0. How do I solve something like this? Remember, I have to create a table. The first factor, the second factor, the next factor, and then the product. The whole thing. So x goes from -infinity to infinity. I need to find the 0 for this, the 0 for this, and the 0 for this, and put them up here. And they have to be in the correct order, from smallest to largest. So, when is this 0? When x is? So the first factor is 0 when x is?
0.
Oh, of course. The next factor is 0 when x is?
-2.
Perfect. And this is 0 when x is?
1.
Excellent. I put them on the side to make sure that I write them in the correct order. -2 is first, 0 is next, and 1 is last. So this one is 0 under 1, this one is 0 under -2, and this one is 0 under 0. 0 for the product, 0 for the product, and 0 for the product. Now I need the signs. This has a negative slope, looks like this. It comes from and goes to. So what is the sign before it crosses the x-axis?
Positive.
Indeed. So is this one, because it has a negative leading coefficient. But this one looks like this, because it has a positive leading coefficient, positive slope. So it comes from and goes to.
Negative to positive.
Negative to positive. Excellent. One negative. No negatives. One negative. Two negatives. I only count the negatives, the positives don't mean anything. Which sign do I want? Which sign is less than 0? Negative. So I am after negative. The equal symbol is there, which means this and this. So then the solution x in the interval, negative infinity, negative 2 with a bracket because of the equal symbol, union, both with a bracket, 0, 1. Any questions? Any questions?
No, no questions.
Okay. Let's also graph, do you want a polynomial or a rational function?
Can we do a rational?
Very good. So let's say we have x plus 1 over x minus 2. Good. I need a domain. I can't continue or start anything without a domain of a function. Can anyone give us the domain? Anyone can say anything about the domain of this function? We had rational equations a few minutes ago, and we stated restrictions for those rational equations.
It can't be 2.
Indeed. So I have to have 0, and I have to have 2, and nothing under 2, which means x equals 2 is a vertical asymptote. Good. Now, what is the horizontal asymptote for this function? What type is it? We looked at 3 types, type 1, type 2, and type 3. And we know what happens to, or how we determine the horizontal asymptote. For type 1 and type 2, and type 3 has slant, does not have horizontal. Anyone can tell us what type is it? Is it type 1, type 2?
It's type 1.
Yes, it is type 1 because because it's the same degree over same degree, and then y equals the leading coefficient over the leading coefficient is the horizontal asymptote. So 1 and 1, horizontal asymptote. When I plug in 0, I get negative 1/2. When is this fraction 0? When? When is any fraction 0? Only when the fraction is 0, only when it's what? A fraction
Numerator is 0.
Only its numerator is 0, indeed. So its numerator is 0 is when negative 1. So let me write this here. X plus 1 over x minus 2 is 0, and we know cross multiply, right? When x plus 1 is 0 or x equals negative 1. Good. Now I only need the sign here. I know that since it's a vertical asymptote left and right, it has to be infinity. But it could be positive, positive, negative, negative, positive, negative, negative, positive. I don't know. But if you remember what we do, we plug in these 2 test points, test values. I'm not going to graph them, but if I plug in, so the numerator is positive no matter what. But if I plug in 1 over 9, 1.9 here, what sign do I get? 1.9 minus 2 will give us the sign because the numerator is positive no matter what.
Would it be a negative?
Of course. And if I plug in 2.1, what sign do I get?
Positive?
Indeed. That's all I need. So we're ready to graph. This problem should not take more than 3 minutes. I have to graph the asymptotes first. So 2 and 1. Label them, please. And now I read my graph. And of course, I have to plot 0, negative 1. And I'm sorry, negative 1, 0, and 0, negative 1 half. And now after I plot those points, all I have to do is follow the table. So from approaching 1, crossing the x-axis at negative 1, 0, crossing the y-axis at 0, negative 1 half, and getting closer and closer to the vertical asymptote, dropping to negative infinity. Again, from approaching 1, crossing the x-axis, crossing the y-axis, and going to negative infinity on the left-hand side of the vertical asymptote. Very easy. On the other side, it's coming from positive infinity down to 1. From positive infinity, approaching 1. Done. So f of x, x plus 1 over x minus 2. Is this okay?
Yes.
Okay. I can't think of anything other than just another word problem. Let's take a look from those quadratics. Quadratic function, quadratic models. Okay. Functions and models, complex numbers, quadratic, yes. Okay, so that's my, what is it? 16. So a rectangular park, so this is problem 139 on page 171. A rectangular park is 4 miles long and 2 miles wide. Okay. How long is a pedestrian route that runs diagonally across the park? Okay. Good. So this is rectangular, meaning this is a right triangle. Anyone remembers what formula or theorem can be applied in any right triangle? Anybody remembers? In any right triangle, we can apply a formula or a theorem.
The a squared plus b squared equals c squared.
Yes. So I want to, it's perfect. However, only if we denote this by A, this by B, and this by C. So what I would like you to remember is the sum of the squares of the legs, that is a better way of remembering it, equals the hypotenuse squared. So it's always the longest side squared is the sum of the little legs squared individually, separately. So then we have x squared. 16 plus 4 is 20. And yes, we have to take the square root as we always did. But this time I cannot write plus or minus. I will. And this is 4 times 5. But then I will cross it out and say x only to the square root of 5. Only because x is a distance. This is correct. But since x is a distance in miles, I can only use the positive number. Okay, here's another. 146 on page 171. A rectangular parking lot has a length that is 3 yards greater than the width. So a rectangular parking lot has a length that is 3 yards greater than the width. What equation I have to write? The length is 3 yards greater than the width. How do I write that? The length is 3 yards longer than the width.
Is it x equals y plus 3?
Excellent. Let's read on. The area of the parking lot is 180 squared yards. Or yards squared. Square yards or yards squared. Good. So I'm given a second equation. How do I write the second equation? I have two variables. I need two equations. The area of the parking lot is 180 squared yards. Find the length and the width.
Is it x times y equals 180?
That's it. How do I solve such a system? Nonlinear system of equations. What should we do? We've studied systems. So what should I do now? Look at the two equations and say, ah, it's right there. So what should I do?
Can we substitute x in to the second equation?
Very good. I'll replace this by y plus 3. And careful how I write it, because I have to distribute. So y plus 3 times y equals 180. And this is not that good. So I distribute y squared plus 3y. This becomes quadratic. Very easy. Here it is. Apps. 9. Quadratic. No, not degree 4. Degree 2. Yes. Punch in the numbers. 1 is okay. 3 is okay. And negative 180. Okay, give me the answer. 12 and negative 15. So y equals negative 15 and y equals 12. Of course, I'm not going to accept this. It's a length. So then y equals 12. If y equals 12, how much is x? That's it. And of course, our claim is 15 comma 12. Is it true? I don't know. I have to check. So 15, 12 plus 3 is indeed 15. Is 12 times 15 180? So 12 times 15. So this is 60, 120, 180. Yes. I can't think of anything else, but I want you to say, I want this, I want that, and then we'll go back to it. Any questions? Any questions?